Every day from our kitchens, our markets, our restaurants, millions of organic waste are produced, and these wastes are sent into our landfills, which is not a sustainable method for dealing with food waste. So after we eat, we deposit it in bins. This usually is the end of our trash. It goes into the environment. It's usually picked in cars such as this, in bins, and then it's just deposited. Sometimes in a controlled landfill, sometimes in an open dump like this. But this is something that we must avoid if we want to ensure continual environmental sustainability, because this, frankly, is not sustainable. Come with me. This is a supposedly modern landfill. A hole dug in the ground, waste put in, covered with wood, away from the world, all our problems down there. But whatever is in there is causing a lot of odor. It's possible that it's going to pollute the underground water by leachate just sipping into the underground water. It's cost maintaining this facility, and it's very, very, very untidy. If I open one of these hatches, it is an eyesore filled with flies, waste paper, waste food, everything. And frankly, quite frankly, the stench is unbearable. But what if I was to tell you that there is a better way we can do this? First of all, it will help us in our nutrient cycling. It will also help us produce residue we can use for agricultural purposes. And it can also produce something we will use for aquaculture and feed for poultry. These are the larvae of the black soldier fly. Now these larvae have the ability to consume various forms of organic waste, converting these organic waste into a nutrient-rich larval biomass, which can be used to replace fish in feed mills, can be used in aquaculture, and it can be used poultry and other forms of animal production. In addition, they can also produce what we call the residue, and this residue, almost soil-like, also has been proven to be very good for crop production. Hello and welcome to the Black Soldier Fly project. Here at Kenro's Channel Mine, what we are trying to do is to use the larvae of the black soldier fly to treat organic waste. We'll start off by looking at how the eggs look like. The egg is usually ovoid and beige in color. This is roughly about 5 grams of the eggs that we have here. What I'm going to do is, after collection, I'm going to weigh them, and then we are going to see how much we have to be able to estimate the number of individuals that we have. So let's go to the weighing machine. See.
So we have about 15.35 grams of it. And I will record this 3588. Today being the 30th of May. Now, after I weigh it, the next step is to prepare it for incubation. These are examples of what we've already done. That is the incubation. These are the eggs. What we do is that we don't put them directly on a food source. You place the food source underneath, and then you put the eggs on a dry substrate up, so that after they hatch, they find their way into the substrate. What we have here is brewery waste from a local drink we call pito, and we use this as a substrate for incubating the eggs. It has the right moisture content, about 70%, for it to do a very good job. The nutritional content is also very good for us. So all I do is just put it in this bowl. Now that will be enough to incubate the number of individuals that we have here. I wash my hands and proceed to incubate what you have. So just all you need is something that will just elevate the platform on which we will incubate the eggs, and just put it on that, and then just put the eggs on it. So that is it. But in order that the eggs don't become clustered together, what I do is just separate it, just spread it gently over, and we expect that in 4 days time this would have hatched. So this is an example of what we did earlier, and I'm going to show you how they look like after you've incubated them for some time. So if you could see, they are very tiny at this stage, but there are a lot of them in there. I don't know whether you see them clearly, but those are the larvae of the black soldier fly. And it's at this stage that they consume organic waste and turn them into very good residue which can be used for agricultural purposes. And again, the larvae itself is protein rich, not just protein but nutrient rich for animals to feed on. So that is the process for incubating the eggs of the black soldier fly. But one of the tricks is that you have to make sure that you control the temperature. So in here the temperature is controlled. We have monitors monitoring, so it's about 28.7. Humidity is about 76. Usually humidity should be between 60 and 80, which is good. And then the temperature 28 to 32 is good enough to be able to incubate the eggs. After we finish the incubation and they are about 6 days old, we take it to our waste treatment area, which I will show you next as we go, so that you know how they consume the organic waste and how the end product looks like. I've covered the incubator. The reason is very simple. If you are not careful, a lot of ants get into it. They will consume all of your larvae in a short period, and also to prevent other flies and other organisms from having access to the incubator. You see that on the stand too, we've placed bowls, and in the bowls there's oil. This is also to prevent ants and other crawlies from crawling up into our incubator. So that is it for the incubation of our black soldier fly eggs. At this point, I'm going to show you the entire facility like I discussed previously, where we treat the waste and where we generate what we call frass, that's the end product, which has been proven to be very good for soil facility. So this first chamber is what we call the intake tree, and this is where we store the end product that we have. This facility is where we treat the waste in about 10 cells, and then we have a waste receiver area. So let's proceed to the area. So normally the waste will come in from our kitchens and the various workplaces in bins like this, and you see examples of some of the waste. So it could include restaurant waste, it could include fruits and vegetables and various forms of waste. So that is what you see. When it comes like this, we just don't inoculate it into the cells. What we do is that we mix it at a certain ratio, and we also add other foodstuffs so that the moisture content that we get is right. So he is going to take a sample and he's going to weigh, and we are going to place it into the cells. So for example, today's second in cell 9, he's going to put 6.8 kilograms into it. So he'll measure and then come and inoculate the cell. So this is an example. This is how it comes fresh. The food sample that has been, we have measured, we've looked at the moisture content and other parameters. So these are the larvae, which are about 6 days old. I don't know whether you see them clearly, but these are the larvae at 6 days old, and I'm going to inoculate the sample. So like that, I put it in. That is it. So in about 10, 12, 13, 14 days, between 10 14 days, we expect it to have changed to a form, which I'll show you soon. We expect it to have changed to be something like this. See? So we've taken something which is a problem and which you would probably have to landfill, and we've turned it into something that is useful. In addition, the larvae has now grown astronomically from being as small as that to a pupae size of about 150, 160 milligram. And this is also nutrient rich and can be added as feedstock for pigs, for aquaculture, for chicken farming. So we are helping with the nutrient cycle. Good. At this point, I'm going to show you how the black soldier fly larvae have been able to compost. This is basically restaurant waste with fruits and vegetables, and it's been about 10 days or 11 days roughly. Let's see how the waste looks like now. So this is what we are basically looking out for, that they will be able to turn it into what is known as frass, that is insect poop, something like that. This insect poop, researchers have found that it's very good for crop growth and can also serve as fertilizer. So this is how it looks like And cell 4 is nearly done. Still, there is a little bit of the larvae inside, but they will just crawl up into this chamber, and then we will just come and take them and weigh them. So that is for cell 4. Let's see cell 5, which is also about 14 days old now, and how it looks like now. So that is also cell 5, which is about 14, 15 days old. And this is what we've been waiting for, looking out for. Same way, you can see that the larvae have come in here. They've started pupating. They have the large instar stage. They will pupate. And an example of them coming up. So that shows what happens to the organic waste after a few weeks of treatment with the larvae. All you have to do is get your moisture content correct. Make sure you know the age that the larvae are in, and then you know how much to put in. And this is the finished product, which you can bag. And from laboratory analysis, NPK and other forms of minor and micronutrients are very good and rich for plants. We'll do a field test next to find out how good it is for crop. At this point, what I'm showing you is how we take the pupae from the treatment cell. And then from the treatment cell, I just go to my weighing scale. Zero it. So we have about 1 kilo of pupae. I put it into the pupation box. And then I'll take it into our insectary. So as you can see, that is the insectary. Come, let's see the insectary. Now, in the insectary, you find that I have a lot of the pupation boxes in the insectary. You find a lot of the flies also flying around. So what we do is, as we keep these guys in the pupation box, after about 2 weeks, they would have emerged as flies, and roughly 5 days after the first one would have emerged, almost 90% would have emerged, and we release them into the insectary. So this is what we do, and then you start them fly away. In the insectary as well, you find out that we've placed bait in here. It could be chicken waste, it could be meat, it could be any organic waste that will just generate smell. And then we leave this banana or plantain leaves for the insects to lay their eggs on it. So these are examples of their eggs and what I showed you first. So this is what we take back into the lab, we weigh and then we incubate. So this is how it looks like. Inside the insectary again, you find that we've planted greens in here. This is just so that they feel as if they are home. So you see, and my man here has been spraying them the whole day and making sure that they get enough moisture. So we have a lot of the bait in here just for them. So And then again, you find out that the insectary will have transparent roofing sheet. This transparent roofing sheet is also to ensure that we have enough sunlight in this room, because we know that sunlight stimulates them to mate. Let's see if we have examples of them mating. Okay, so you can come catch this. So this is an example of the flies mating, and after mating, 2 days after mating, their eggs become matured enough, they lay them, and then they are fertilized. So this is our insectary for the black soldier fly, and these are the guys that we call soldier fly. There are a lot we can learn from them and what we do for the environment. That guy is gone. So what it is showing you currently is them congregating in an area, and you can see that they are trying to mate. The two of them wasn't successful. He goes to the other one. That is what we want to happen, and the insectary is voluminous enough to accommodate all of our flies and to generate about 2 grams of eggs almost on a 3-day basis. So in a week we are looking about 4.5 grams of eggs for our process. The good thing is, even as at now we have just 10 cells, we are able to do about 40 kilos a day, which is quite substantial. So to do about 1 ton a day, we would have to estimate the cell space, and then you would have to also improve on the number of eggs or individuals that we get per day, just so that we will get the number that we need. So though the black soldier fly, they don't eat at the adult stage, they don't drink water we've not known them to drink, but what we do is that we just spray the insectary with a lot of water to keep them wet, and also to keep the plants and others wet, because it's been proven that if you spray water on them, you expand their life span. So instead of them living 4 days, 5 days and dying, we've seen that some of them can live as much as 6, 8 days before they die. So that is it for the insectary of our black soldier fly project and the processes that goes on.